You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Since its inception, Amazon Web Services, AWS, has been the best place for customers to build and run open source software in the cloud. AWS is proud to support open source projects, foundations, and partners.
All right, everyone. Hey, thank you so much for being here. This is very exciting. Is everyone enjoying KubeCon? Awesome. Well, tonight I want to thank the AWS Open Source Group for having this event, for this discussion that is, I'm sure, going to be enlightening for all of us. For we have two very distinguished people, and as I was saying before, one of those people actually has distinguished in his title. But I'll get to Kevin in a sec, but first I want to introduce Jesse Butler. Hey, Jesse.
Hello, good to see you again.
And Jesse is a principal product manager at Amazon Web Services. And Kevin Klues, a distinguished engineer from Nvidia. Thank you both for being here.
Thank you.
Now, I'm going to be having a conversation here, but start thinking of things that you would like to ask, and we'll make sure that we can get your questions answered. So I want to just start off talking with both of you about who you are and what your backgrounds are, because you guys do work together. But I'm curious about how you came to where you are today. So maybe we can start with you, Jesse, to talk a little bit about that. Tell us a little bit about your career trajectory, and maybe you could tell us a little about when you started really thinking deeply about the world of AI. I'd be curious about that.
Sure. Thanks for having me. It's good to see you again. I'm an engineer by experience. I was an engineer for like 20 years. I worked on Solaris at Sun Microsystems, if anybody's ever heard of that.
Yeah.
So I wrote drivers and stuff, and then worked my way up the stack, got into virtualization and containers. And I got involved with containers and the Open Containers Initiative and Docker and Kubernetes pretty early. And I joined AWS in 2020 into the EKS product team. So that's how Kevin and I have found working with each other. I think in open source, right, we have a sort of same team, different company. So for a brief period of time, we were working on the same thing together, and now we know each other, and it's great to be here with them.
And I'll ask both of you all this, but AI has been around for decades, but it always seemed a bit like a distant star, didn't it? When did you start to think of it as like not so distant and something that actually is something that will be integrated into cloud native architectures?
Yeah, we were just talking about this earlier. I think neural networks and AI have been around for a long time, and I have people in my world have had did doctorate work on it in the 90s, right? I think the thing that made it more accessible is LLMs and generative AI.
Yeah.
It's changed, it's kind of paradigm shifted how we can leverage all of the stuff under the covers through an abstraction.
And that's a key word there, abstractions. Kevin, I'd love to hear about your story. I know you worked with Mesosphere, but before that you've been in academia, or haven't you?
Yeah, that's right, yeah. So I did my PhD at UC Berkeley, working on developing an operating system, which at the time was meant to be kind of a dumb node OS on top of which something like Mesos or today Kubernetes would make use of in order to schedule workloads and run them and just be able to get access to all of the hardware that was available to it without having to jump through a bunch of hoops or jump through a bunch of abstractions to make that possible.
Were LLMs that moment for you when you realized maybe the realities of like this new abstraction would have an impact on your work and the way you thought about the work that engineers around the world would be working?
Yeah, it's funny. So as Jesse was saying that, I was actually thinking my kind of aha moment was more once the hardware reached the maturity level that it had. So these algorithms have been around for decades, but until we had the hardware that could actually accelerate it properly, that's when it really started to take off in mainstream.
So, AWS and Nvidia work together, but I'm curious on how the two of you work together. What is the basis of that work? what is it that you're doing on a day-to-day basis that then has you come together and think about things and then continue to develop and move along?
Sure.
I could probably start that because
Sure, yeah.
I have the sort of simpler approach. So we just had customers that needed to use GPUs more effectively. So kind of as Kevin was saying, right, the GPUs have reached a place where we can do amazing things, and we're capable of building tooling and abstractions on top of it, putting them into computing environments where you can actually leverage them, where you don't have to be a physicist to do that. You could just be like a bank or a healthcare provider. And so a lot of our customers at AWS want to leverage that. And a lot of our customers do that through Kubernetes, which we're at KubeCon. We've seen Kubernetes become a standard, sort of a way to consume other resources. And we, through our partnership with Nvidia, we're trying to work on a way to actually help improve that, right? Like, you have all these GPUs, what do you do with them? How do you use them in Kubernetes? And how can we make it easier? And that's how Kevin and I got involved, because he had been working on this project called DRA.
Yeah. Well, so in general, the team that I'm on at Nvidia, we kind of the 5-minute elevator pitch is that we build the foundational components that allow GPUs to be usable in containers in Kubernetes. And so one of the key abstractions that we've been working on over the last couple of years is this feature called DRA, or dynamic resource allocation, which really kind of enables these accelerators and specialized hardware to be allocated and used in the Kubernetes environment, which wasn't really possible before with some of the abstractions that existed beforehand.
So with those abstractions, we keep hearing this term, abstractions. How are you thinking about abstractions now? We had interesting conversation just beforehand. It gave me some, a bit of insight into how we are starting to view abstractions with the emergence of natural language models.
Mm-hmm. I think one of the things that I've seen in my career, starting pretty low level in the operating system and working my way up, I've talked with customers and other engineers about leveraging some of the sort of the technologies that are available in that stack. And I think one of the most important things that we figure out how to do is to abstract for simplicity, to make complex things possible. I think as Alan Kay, I'm maybe paraphrasing him, simplicity and abstraction are kind of married, but the solution isn't to make something simple. You don't dumb it down. What you want to do is create new APIs and new constructs that help you use that complexity to your advantage. Really sensible defaults, nice, elegant programming models that allow you to access that complexity if you need it. Get granular if you need to, but in other ways, just let you kind of consume things and move forward with life. So trying to take this very complex set of things and move it up the stack and up the stack, where we're getting these sort of primitives that you can build with. That was, that's kind of always been the mission of my career, and I think those are the successful things that we see in Kubernetes that come through this standardization layer of having things like DRA, which I think is one of the most elegant things I've ever seen, right? You just take all of this complexity of GPUs and all of the things that go into that. Far more than just GPUs. And as Kevin said, DRA isn't just about GPUs, it's about any specialized hardware. But even looking at the work we did for GB200 and to bring that out to the market and through, not only through NVIDIA's NVL72 product, but also in the cloud in AWS, it took a lot of work to think about what does a customer need to make use of this, and what can we do on their behalf?
Yeah, that's a good way to put it. I think the way I tend to think about abstractions as general is what can we provide to an end user that they can consume and use to ease their path towards being able to make use of some feature. And that's exactly what DRA allows us to do is, third-party vendors can come in, bring along their own device driver to enable a piece of hardware to be accessible to users of Kubernetes in a way that wasn't possible with the traditional device plugin API that we had. And one of the niche use cases that we found is that, as you pointed out, GB200, we built a system around using DRA to allow not just a single node, but multiple nodes within a single GB200 rack to communicate securely by abstracting this notion of a multi-node NVLink and allowing users to kind of allocate the entire multi-node NVLink connection rather than just an individual GPU.
I want to get to this question about the challenges that we see right now and how you're thinking about them in terms of orchestration and resource management. But I'd love to dig a little bit deeper on DRA if you don't mind. Like, what makes it so elegant, and how did it generate out of of what you were doing? How did it come to be?
Sure. Yeah. So the entire DRA model is sort of built around a similar model that was designed for storage systems years ago. If you've ever worked with persistent volumes, persistent volume claims in Kubernetes, the abstractions that DRA provides look very similar to that. You create this thing called a resource claim. You've got this thing called a device class. And so, the ideas aren't really new, but we built DRA to be able to allocate and make use of generic resources, not just storage systems. And in fact, Patrick Oley, who's one of the other leads on the DRA project, he said that if he could go back in time, he would have written all of the storage system stuff in terms of DRA instead of the way that it evolved back then. And so, that's how it kind of had its start, but it's evolved into a lot more than that now. Kubernetes kind of hit this point where, we needed a way to not just work with fungible hardware. We needed a way to actually get access to specialized hardware and request exactly the type of hardware that we need access to. And the abstractions we had before didn't really allow us to do that, because the only knob you had in the old way of requesting access to resources was a simple count. You could do something like ask for nvidia.com/GPU2. You could say I want 2 GPUs, but you couldn't say what type of GPU. You couldn't say how you might want that GPU to be configured once it's given to you. And DRA really allows you as an end user to express these more complex constraints on what you want access to. And then the complexity of how to actually make that happen is built into the Kubernetes scheduler, into these vendor-specific plugins that are running on individual nodes to make all of that kind of transparent to the end user. And at the end of the day, all they see is that their workload now has access to the hardware exactly what they asked for.
That becomes very relevant then to the end user, doesn't it?
Yes.
How so?
Well, so I think exactly as Kevin said, right? If you have a job to do and you need a particular type of GPU or you need a certain number of GPUs, the idea of effectively Kubernetes is extensible, right? That's one of the reasons that it succeeded really well. So you could go write yourself a controller and somehow figure out how to make that controller allocate a claim on a piece of hardware. You've got to go find the piece of hardware. How do you connect that to your business logic in your controller? That's what we're solving with DRA, right? It's very much the same way as saying, well, I'm in the cloud. I've got, for example, EC2 and VPCs and EBS volumes. What more do I need? That's why we use Kubernetes, right? If you can figure out how to go schedule 2,000 processes across any number of resources and not have to worry about scheduling it and orchestrating it and replacing nodes, you just reinvented Kubernetes.
Right.
So the idea of then building your own custom solution to figure out this problem of saying, I need these specialized pieces of hardware, this accelerator, this GPU, it needed a standardized solution. What that enabled us to do is to build a product like the GB200 EC2 instance and just use DRA. You could just use DRA. Use Kubernetes and DRA. Here's a blog. It shows you how to do it in 3 steps. There's 18 lines of YAML. You don't have to write a CRD. You don't have to figure out those things. The really nice thing and elegant thing about it is that you can configure it if you need to. You can get in really deep. There's granular configuration that's available to you, which kind of gets back to that thing of abstractions. Abstractions still need to respect the power that they're abstracting, right? If you want to build a fleet of agents that are going to run, that's probably going to need inference. You're going to need a model. You're going to need GPUs to run that. Kubernetes is where people are doing that, and kind of DRA and that work that Kevin and his team did enable that.
And one thing I just want to say when you said Kevin and his team, DRA is a community effort.
Yes.
Lots of different companies are contributing to it. Lots of different companies and just users in general are making it possible. It's not just the team at Nvidia.
Yeah, I should have said Kevin and the team, and because that team I meant was the community team.
I want to get back to this community discussion in a minute, but with the emergence of DRA, one of and other advancements, one of the real striking things I think about this year at KubeCon is how we've reached this almost like this inflection point right? Now it's not about where maybe in past KubeCons we talked a little bit about AI. It was starting to come on the radar. There was like a keynote I remember about Ray at a recent KubeCon, but it was almost like fragmented a little bit. This year it seems like it's a lot more unified, right? So a lot more people are talking about it. You're getting a range of opinions about what that means for them. So, but I'm then curious, like, if you're taking in all that feedback and you're thinking about it from your own point of view about what you're learning, what are some of the key challenges that you're seeing in Kubernetes orchestration and resource management?
Sure, I can take this one. So, DRA is great at what it does. It allows an end user to request access to hardware. Those resources get injected into a pod. Scheduler takes that, puts it on some node, and that pod comes online with access to those resources. But sometimes it's not enough, and this is very relevant even in like the GB200 use case that we were talking about a minute ago. It's not always just about running a single pod somewhere. Lots of times you want multiple pods in a multi-node workload to come up simultaneously. Or you want to be able to express things like, I can have some subset of these pods come up, but if I can't get all of them or I can't get exactly that amount, I don't want any of them to come up. And at least today, you can't really express that in the Kubernetes world. And so we're working on a new abstraction called the workload abstraction, which, DRA reached GA in Kubernetes 134 back in August. There's obviously still lots of work to do in that area, but this new workload abstraction that we're working on is kind of the next big thing that we really need to pour a lot of resources into to make it a reality in Kubernetes.
What is it exactly then, the workload abstraction?
It's going to be a CRD, so it's a way to express both a grouping of pods that have some type of scheduling constraints put on it. So you might say, I want this group of pods to be gang scheduled. I mean, they all have to come online, or none of them should come online.
Okay.
And on top of that, you can specify topology constraints there. So you can think of it kind of as a node selector on steroids, right? You can instead of just saying this pod needs to land on this node, you can say this group of pods needs to land within these topological constraints, subject to the scheduling constraints you put on it, like whether you want it gang scheduled or not. And there's none of this is so a very basic implementation of this is about to be included in Kubernetes 135, coming out next month.
Okay.
The very basic, bare bones implementation of this, but there's lots and lots of work, and there's lots and lots of unsolved problems in this space. And so we welcome everyone from the community to, share their ideas on how this should take shape, because it's going to, shape the future of how all of this works for the next 10 years of Kubernetes.
Okay. I was going to ask you the question about the challenges that you're seeing for both orchestration and resource management.
Yeah, I have sort of the top of the funnel set of problems related to that same thing. So what we have is a lot of customers that want to embrace AI, and it's more on the sort of agentic AI, where we're looking at, training has been a boom for a while. We're now looking at inference and customers wanting to build agents, fleets of agents, making them work together. We're sort of seeing like the LLM having moved the stack up. And so I think customers are starting to realize that agents are sort of like a microservice. So you can start architecting sort of whole applications or whole systems using agents where you would have maybe had a microservices architecture. What that means is those need to work seamlessly. Right, so what we don't want to do is walk away from all the problems we've solved over the last 10 years with getting processes up and running on CPUs through Kubernetes. So, looking at things like not only, DRA for resource allocation, but also like new types of scheduling, new types of like defining workloads are going to be really, really important, because we don't really know what customers are going to build over the next 12 to 18 months or what those patterns are going to be. But we're pretty sure that it's going to be something around agentic AI and fleets of agents working together, sort of informing each other through context, having shared tools, looking at things like A to A, agent-to-agent communication. All of the substrate below that needs to just work.
Yeah, and the way I like to think about that, and I say this a lot, but it's the separation of mechanism versus policy, right? We're providing this mechanism for people to then define the policy on top of how they're going to make use of that in all these interesting ways that we don't even know yet.
Yep.
I'd love to see a show of hands. Who has been experimenting with agents? See a handful of who? I'm sorry, what was that? Not in your house, okay. Good, there's a handful of people there, which is interesting, which I think speaks to then the requirements almost for people like yourself to really focus on community. I mean, we're talking about a little bit higher up on the stack, right, with Genetic AI, but in the work that you're doing, this will enable that. Mm-hmm. So what are you doing from a community perspective, and what do you hope to do, as we kind of move into the new year?
Yeah, so from the stuff that I work on, so we have a working group, Kubernetes working group called the Device Management Working Group that meets, every other week at 8 a.m. California time, and this is where we all get together to kind of share the ideas about new features we want to add to DRA, and then also this workload concept that I mentioned. We're also discussing that there, and that's kind of the venue to share these ideas and help push it forward for the foreseeable future.
So what are some of the things that you've been focusing on, like let's say in the past 3 months? Can you name a few things?
Sure. Yeah. So from my perspective, the most critical feature which hasn't kind of reached a level of maturity that it needs to in the DRA space is this ability for DRA drivers to honor the old style resource requests. Because until we have that capability, DRA is not going to gain widespread adoption. Because not everyone's going to want, because DRA is a different model for how you request access to resources. And if you don't have a way for people to take their existing workloads and run them on a DRA-enabled system, it's going to be really slow for it to gain traction. And so we have a feature that we're working on right now. It's still in alpha, even in 135 coming out, but we're hoping to graduate it to beta in 136. And with that in place, it'll be transparent to end users whether they're running a DRA, whether their admins have decided to run a DRA driver on the system or the device plugin, their workloads will just continue to work even if they're asking for resources without this more complex, well, I shouldn't say complex, this more feature-rich API that DRA provides them.
Because people are working all kinds of, there's all kinds of resources out there. And so you need to be able to have that capability to
Well, I think it's more that people are slow to migrate to the new APIs. They want to be able to continue running the things they've been running with the exact same pod specs, manifests that they've had up until now, and they don't want to change everything they're doing just to accommodate DRA. And this would allow them to do that.
Mm-hmm. Great.
For us, sort of in the EKS service, one of the things that we're primarily focused on in community is standards. So we really want to make sure that we can help all of this work kind of move forward. You have a place to build and test, with this work, and that customers can eventually use this. So I think, part of it is around the AI conformance stuff that's been really kind of bubbling up recently. It's very exciting to be able to be part of something where we can say, yes, this stack or this solution is going to be conformant with these specifications, right? And the other piece is around topology, right? Topology has sort of been the Wild West for a while. And so if you look from sort of environment to environment or product to product, we've all kind of come up with our own topology keys. And as kind of boring as that sounds, it's really chaotic for trying to make something work in multiple environments. So again, kind of respecting the reason for Kubernetes as a standard, you want to adopt it, especially as an enterprise. It's portability, right? It's being able to just use these APIs. You don't want these differences between environment to environment. So those are some of the things that we're looking at, trying to kind of just unify. For our part in the community.
Yeah,
great. Yeah. Go ahead.
We're plugged into the AI conformance effort, and so a sub piece of that is actually having DRA driver conformance.
Right.
And it feeds into the overall AI conformance effort that's going on.
I at this point would love to see if there's any questions out there that anyone has about what we've heard so far, or about anything. Are you looking to? One thing that I've been really learning about is the need for people, right, to do this kind of work, not just in the community, but there's lots of roles to be played. Anyone have any questions that they'd like to ask? There we go.
Can you come to the front so we can hear you? Right, coming up here, sorry.
We can't hear you guys.
Oh.
That's not good.
Okay, well, we're trying, yeah, we've had some issues with the feedback, so you haven't been able to hear anything we've said so far, basically?
You stood in the back of the room and I could hear you in earshot, but we'll digress a little bit.
Okay. Well, let's get a question so we can maybe, then I'll really speak up, okay?
Thank you.
See if I can carry it.
Okay.
Nolan Code. Question. So, I guess my question is more about efficiency versus rigidity, right? I think of like the transformer itself is not very sophisticated, but it's efficient, right? Like nature. So, I kind of think of like containerization being the cell in that network, right? So, I'm wondering overall, are we looking at more of like a large signalized brain or a more efficient platform in terms of what we're building in the future? If that kind of makes sense.
You're talking about the full stack of
Yes.
from Kubernetes all the way up to the application that's running. Yeah. I don't know if Jesse, you have any thoughts on this?
I don't know. I think one of the things that the community itself even sees Kubernetes as is like a platform. Right? We think of it as a platform, and then you build software on the platform. And I think one of the things that's really important that I hope, oh, actually, should I talk louder? Sorry, it's better. Okay. So a good question. So I am a big, I'm a big fan of thinking of systems, right? So if Kubernetes is a platform, is it actually a platform layer? Is it an API? It's actually like sort of where you run the software. So the software and the platform together are the system. I think as far as like the thing that we think about of the future, what are we trying to improve? What are we trying to build is a system, right? And this has evolved over years. It's gone from wire wrap boards and transistors and stuff through CPUs and racked and stacked stuff in data centers. Now we're in the cloud. We have Kubernetes to abstract it, to make it a platform, to make it portable. The software you run on top of it, now you have a system. I think the thing that AI is going to really push is where the delineation is for the things you need to care about. And again, if you kind of look back in time, C was a high-level programming language at one point because it wasn't assembly. And then we had the Python and JavaScript, and now you've got the cloud abstracting things. You have Kubernetes as a system. You can run your containers. We have agents now running on LLMs. So I think you still have to respect the fact that there is a system there. I think there's just a question of what layer you care most about. And like planning for the future, do you have to worry about Linux anymore? Or do you just think it's there? Do you have to worry about device drivers, or that they just work, right? So at some point, is Kubernetes just going to be a thing that's there and it works, and now you're worried like a level above that? I think that for me, thinking toward the future as far as like architectures, that's how I would remember that there is a system. That's the software and the platform, right? You have a standard open platform that's extensible. Check with Kubernetes. So now where does your software live? That's kind of how I think of it.
One thing that occurred to me as you were saying all that is that it's a quote that I heard a long time ago, and I repeat quite often, but it's, as a low-level systems engineer, if you do your job right, no one knows you exist.
Yeah.
But the minute you do your job wrong,
everybody knows.
Everybody knows you exist. And that's kind of, Linux has become this assumed part of the system. Maybe Kubernetes will be at some point. But the minute something goes wrong there, everyone's aware that that's the problematic layer.
Yep.
Yeah.
How about another question? All right, we have one in back here.
So my question is, there's a very big emphasis on LLMs, especially as a component of agentic AI. We're also seeing kind of a shift towards small language models, or at least in the future, it would be great to see that shift, that are very specialized for very specific tasks and are much more power efficient, among other things. Are there any considerations from the perspective of Kubernetes, DRA, and the work that you all are doing for optimizing across small language models versus large language models?
Yeah, sure. So I don't know how familiar you are with a feature called MIG that Nvidia GPUs provide. It's a way to take a full GPU and subdivide it into a smaller set of kind of mini GPUs, you can think of it as, that are fully isolated from one another in a way where you can actually, they're capable of running multi-tenant workloads. And one of the things that we're doing with DRA, which was actually demoed earlier today in a presentation from one of my colleagues, is the ability to dynamically create these MIG devices based on workload requests that are coming in. And so if you have a smaller workload, or a workload that needs a smaller GPU, you put a request for that in, and the system will figure out where there's a GPU that's capable of being sliced up into this smaller piece. It'll create that smaller GPU on it and then start running you there. And then once your job's done, that GPU becomes a free agent again to potentially be a full GPU or some other combination of smaller MIG devices over time. Yeah.
So that abstraction, like I think the flip side of that question, or the other part of that is like, should you be pursuing specialized models, right? Does it make sense to have 50 specialized models when you could just have one large general purpose model? And I think that has just been a question in computing since we started working with computers, right? You have a general purpose operating system and it has everything in it. It's got word processors, it's got all your business applications, it's got this proprietary software that runs this special hardware. We moved away from that model, right? And now you have like applications that you can use on multiple different systems, and you have, sort of more commodity hardware. And it made sense, right? So now if you're going to run a thermostat in your house, you don't need a Honeywell computer the size of your room, right? You just need a little teeny thing.
Right.
And I think we've seen that time and again with application software, with tooling and everything. We start these big, broad projects, and over time they get broken down. So I think it's always going to be a personal question of like, hey, I can just use some model that does everything for me, and it's massive, and maybe it's a lot of exposed real estate. If it makes sense for you, you say, I've got 10 use cases and I have 10 models that are all smaller. I can use something like MIG through Kubernetes. It makes it easy to do. I think it's a great practice because it sort of goes back to some of the Unix philosophy and sort of least privilege, do one thing and do it well, right? There's a reason those rules have been around for 50 years. They work, right? And so yeah, if you can break things down and do things smaller with more special purpose stuff, and it doesn't cause burden, which hopefully things like DRA and MIG mitigate that burden, I think it makes a lot of sense.
Great. We have time for one more question. We have one?
Right here, behind the
There's
light.
one here behind the light.
Great, okay.
Hi, thank you guys for being here. My name is Patrice. You talked a little bit about agentic AI and agent-to-agent communication. I've heard of agentic AI and experimented with it a little bit, but I don't know much about agent-to-agent communication. Can you talk a little bit more about that?
Sure, yeah. At AWS, I think we've been working with LLMs and agentic AI for a while, and we've had an unpopular opinion for quite a bit of that, which is we don't think vibe coding is the way. It's very fun to start an IDE and just be like, build me a thing. The thing gets built for sure, but it might not be the thing you intended, right? So kind of getting back to the question before, right? Doing things in more granular, sort of stepwise processes is going to result in something that is more in your control and maybe a better quality. So the question then is like, can you break that up and do multiple things at the same time? So can you have smaller agents that work as a fleet or as a team? And if you do, how do they communicate? So we've been, along with a lot of other people in the community, been working with this thing, A to A, so agent to agent, having this protocol that allows agents to talk to each other. Leveraging MCP is great because you have context and tools. A to A lets agents talk together, right? I've been doing this for a while on my laptop with a shared file, and they have access to it and they talk to each other. That's not very efficient, right? So building something that's more systemic makes a lot of sense. So yeah, that's what that's about, is sort of being able to elevate your ideas into fleets of agents and being able to delegate work to a lot of agents at once.
Thank you.
Thank you.
Well, that does it. Thank you all so much for being here. Let's give a big hand to Kevin and Jesse. Yes.
Thanks, Alex. Thank you,
Enjoy
Kevin.
your bowling. I'm Alex Williams, founder of the New Stack. Check us out. We write a lot about agentic AI. And check out AWS and Nvidia to learn more about how you can be involved in the community. Thank you again.
Thanks.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.